This is part 3 of section 5.1. We are still trying to verify identities. And for this one, I have two fractions here. I have a secant, which is a cosine, 1 over cosine. So I know that I'm going to need cosines over here eventually. But right now, what I see is two fractions that I should get a common denominator between and combine. So my left-hand side is equal to, my common denominator would be 1 minus sine x times 1 plus cosine x. I'll just write that here. Okay, so if this is my common denominator, then for this one I would have 1 times 1 plus sine x over here, and I'm going to go ahead and multiply those together because it's a difference of squares, and I have 1 minus sine squared of x. Plus, have the same denominator here. And this is over this when we need to be multiplied by 1 minus sine x. Okay. Now, what is 1 minus sine squared of x? This is one of our Pythagorean identities. 1 minus sine squared of x would be cosine squared of x. Okay, so that is my new denominator. And what do I have up here? I have 1 plus 1, which is 2. Sine x minus sine x, that cancels out. So I have 2 over cosine squared of x. And I can rewrite a cosine in the bottom as a secant. So this is the same thing as 2 times secant squared of x, which is the right-hand side. Okay, so let's try this one, and I'm going to work it essentially the same way as this one. We have two things here that will end up being a difference of squares when I get the common denominator, and I'll combine these and hope to end up over here. So my common denominator would be cosecant x plus cotangent x plus cosecant x times cosecant x minus cotangent x. As a difference of squares, this is the same thing as cosecant squared x minus cotangent squared x. And let's see if this is one of our Pythagorean identities. Cosecant squared minus cotangent squared. Cosecant squared minus cotangent squared would equal 1. Okay, so if I get a common denominator here, and this is my common denominator, I'm going to have cosecant x minus cotangent x, and this is over 1, plus cosecant x plus cotangent x, also over 1. Instead of writing this, I'm just writing the over 1. So this is my left-hand side. And then right here, you can easily see that the cotangents are going to cancel out, and you have 2 times cosecant x. We're wanting sines. I've got the 2, which is great, and cosecant is 1 over sine. So this is the same thing as 2 over sine x, which is the right-hand side, which is what we were looking for. Okay, so let's show this one. Secant squared x plus cosecant squared x is equal to secant squared x cosecant squared x. So basically, this one seems a little bit odd at first because it says adding them is the same thing as multiplying them. And I've got, with secants and cosecants, they don't go together in any Pythagorean identity. So I'm going to change these into sines and cosines and see what happens. So my left-hand side secant squared x is the same thing as 1 over cosine squared x plus cosecant squared x is the same thing as 1 over sine squared x. Now if we get a common denominator here and combine them, I'll end up with sine squared x plus cosine squared x is equal to cosine squared x times sine squared x. Sine squared x plus cosine squared x is one of our Pythagorean identities. It is equal to 1. And now if we use our reciprocal identities here, cosine squared x is secant squared x. 1 over sine squared x is cosecant squared x, which is our right-hand side. And so it is an identity. Okay, now for this problem, both sides are fairly complicated. So I'm going to work on simplifying them. Okay, so what do I have right here? My left-hand side, I could get a common denominator here, and it will be these two multiplied together, which is a difference of squares, but I'll have 1 plus sine x minus, use parentheses because we have to subtract the whole thing, 1 minus sine x. And this is going to be over these two multiplied together, which is 1 minus sine squared of x. Distribute the negative up here. Okay, and your 1's are going to cancel, and that numerator is going to be 2 sine x. The denominator here, this is one of our Pythagorean identities rearranged. 1 minus sine squared of x is cosine squared of x. Okay, now I've simplified a lot. There's more that I can do, but I'm not really seeing how to get to here from that. So I'm going to stop here for a little while. It may be that I come back and work on this some more. Don't give up on it. But now, since this side is fairly complicated as well, I'm going to work on that side and hope to end up here, or at least close enough to here that I can see how to make them match. Now, for my right-hand side, I have tangents and secant squared and cosecants. I have a lot of things in here. Okay, but one of my Pythagorean identities is 1 plus tangent squared is equal to secant squared. I have a 1 plus tangent squared. So just to make it a little bit clearer, I'm rearranging the top here and putting this in parentheses so you can see a little bit better what's going on. Okay, and then from the identity, 1 plus tangent squared of x is secant squared x. Okay, so I have 2 secant squared x over cosecant x. Now look here and here. Can I make these match? Well, I have the 2, which is great. Here I have a sine and a cosine. Here I have their reciprocal functions. So if I change this, the 2 is going to stay where it was, but secant squared x is the same thing as having cosine squared x in the bottom. And cosecant x in the bottom is the same thing as having sine in the top, and our two sides are equivalent.